Alright, jumping right back in. I'm going to close this. We're sort of going to rewind here, start from fresh slate. What do we have going on here in this notepad? We've talked about pointers in a variety of ways. We've shown that as Shadowrun.exe is interpreted by, in the context of this process, is always named Shadowrun.exe in Cheat Engine for our purposes, that we can establish that multi levels are basically pointers to pointers to pointers to pointers ad nauseum. With offsets relative to the start of that process is memory. We're fiddling around with that in the last video. And, right at the end of that last video, we started to sort of quantify, why is it important that we know these things, and do I just like hearing myself talk? I definitely do not. We are going to harp on this issue. Why do we have 15 videos about variables? Well, because the fundamental concept and how variables are implemented in a general way is, as we've talked, important to pointers. And are there going to be 15 videos, 20 videos about pointers? It is more than possible that we will, or that I, and as a viewer, you're certainly not. You don't have to watch all that stuff, but we are going to harp on this issue of pointers, and we'll try and make it a little more concrete, messing around with Python, doing some other things, Cheat Engine, trying keep it as a video instead of just me bloviating. But we'll try and illustrate that or as much as possible until we've gone over many different ways to think about them and understand this concept. Because can we go farther down the rabbit hole to bring to use an analogy from a previous, or a metaphor from a previous video? Yeah, the rabbit hole goes as deep as you want it to. You could let's just say that the rabbit hole is extremely deep, and how far down the rabbit hole are we at this point? We're pretty far down. And what is the bottom of the rabbit hole? The bottom of the rabbit hole is basically just bits being fed into the processor, and then that's abstracted out into some mnemonic language, opcodes, and things like that. And then there's some more abstraction on top of that as far as like assembly language, and how that translates from platform to platform. And that's abstracted out even further into some things that sit on top of assembly in a lighter way, but offer some basic data structures and functionality, that makes it easier to work with some of the features of processors on as far as using features of them that are built right in on a sort of like on a hardware level, as the case may be. Then you start getting into the realm of programming languages like C, and C starts introducing data types to deal with pointers, and that's the level that we're pretty much talking about right here. So how far are we removed from the bottom of the rabbit hole? I don't know, half dozen levels maybe, because I'm kind of glazed over some details, and so yeah, I don't know, half dozen levels. But for the general audience and general users, will never know anything about pointers, and nor should they. But in order to effectively use our application of choice, which is Cheat Engine, we have to understand these, or I'm putting forth the idea that we have to understand these concepts, and we are going to beat these concepts to death until we have some uh, natural understanding of them. And so that when we go in and we start jumping in and finding pointers and doing multi-level things and things like that, there's some convenience features that Cheat Engine offers us, specifically the pointer scanner, which we will use and show how to use and what it's doing. That makes our life a little easier. But there's also sort of a manual method, if you will, that you can go around and find values, and we're gonna show both of them and get into it. But in order to understand how the manual method and the pointer scanner works, you can just be content by saying there's a black box. I know the enter values here. I cut this, I paste that. Click this, click that, and then magically I'm cheating. Um, if that's your sort of thing, then obviously there's videos out there that do that, but we're not interested in that approach. We are taking the incredibly pedantic approach, so let's continue with that approach. We've talked about pointers, talked about offsets relative to the start of that process as memory. Sort of have a pretty good hold on that. What are variables? Variables are names for memory locations. Those memory locations in turn have a value. It's a sort of we've generalized it into a three-step process, and that there's some middleware sitting in there at memory management, memory manager, and it does some black magic that allows us as far as a programming language goes, and Cheat Engine and things like that. We don't have to deal with anything super crazy as far as memory management goes. So again, pointers are variables which have a memory location, just like regular variables. So we could just bring it home, x equals 5, as we've done in billions of videos before this. X equals 5, that's a variable name, that's a value. Now when we just say x, or we could say make a new variable, what is our value of our new variable? It's going to be x plus 1. It's really happening. It's taking the memory address of this variable. It's putting it in here. I don't know. Go with, who cares? Doesn't matter whether it's valid or not. Some hexadecimal representation of a memory location. It's going to stuff that in there. It's going to go back. It's going to look at this memory location, which is really this. It's going to get the value, and it's going to come back. It's going to substitute it there. That's great. So see if we can maybe do the same thing with pointers to sort of start beating this concept to death, because God knows we're going to beat it. I'm not going to say that because it sounds rather dirty, but anyway, so we're going to say x is a variable and it's a pointer. So what is the value of x, the pointer? X, the pointer variable. Say we'll just call it PTR as slightly more concise, slightly more descriptive name. We'll say that the pointer is a variable that has a memory location. This is not the memory location of that pointer. This is the value of the memory location of this pointer. So just like we talked about, x is a variable, has a value 5. What's really going on here is that x has some memory location. We will say df, df, df for simplicity. This is the memory location of the variable. In this memory location, there is some value that we have set to some data type, which we don't care about right now. We're just in general terms. And in this memory location, there is some value of 5. A pointer, just like we did up here, and we sort of broke it down. We'll break out the third step here in a second. There is a variable called pointer. It has a memory location, which we'll get to. But this variable PTR has a value of this, which itself is a memory location. And we'll get to how we deal with that. But what's really going on here is that there's a pointer, and we're going to make this something totally different than what the value is for the purposes of illustration. We'll say A0, C0, D0. So this there's a variable. It has some memory location. Who cares where this memory location is? It's all handled, by the memory memory manager, and it's all black box, and we don't have to worry about it. But the value of this variable in this memory location is this. And this is because we've kind of said, hey, this is a pointer variable. It's going to return a memory location. Now we could have some other variable that we'll call it PTR2, which we are just going to say it equals PTR. What does that mean? Are we setting it to the memory location of this? No, we are setting it to the value of this memory location. So we've sort of illustrated here that we're getting into a little bit of indirection. It's getting a little crazy, but we'll get into that more. What we are saying is that variables can be of any type. Pointers are a variable type, and pointers, just like regular variables, have a memory location. It's just that the way that the value of the variable is interpreted is another location in memory. It's just it's a hexadecimal location in memory. It's actually it's just bits, but for purposes of that we'll get into about why is a hexadecimal? Well, it's easier for us to use hexadecimal to express certain types of numbers than it is to type in this kind of crap. Who the hell wants to stare at that? And there's other technical reasons why. It's certainly easier than doing this. Why is it easier than doing this? We'll talk about that. But suffice to say, for our purposes and the illustration, son of a bitch, I don't know, something like that. For our general sort of illustration purposes here, we'll do a little notepad formatting. Regular variable, or what we're just making up this classification. It doesn't really exist in computer science in a tangible way, but pointer variable. So what do we have here? We'll notice we have variable name, we have memory location for the variable, and then we have a value. So let's generalize this out. All variables. Well, we don't want that extra one, God forbid. Have a name, have a memory location, have a value. What is the difference between the first two? The only difference is the value. Regular variables generally have a constant value, 5, 1.0, 1.5, 3.14, or a string, some text, some characters, something. Pointer variables are designed or are explicitly for the purpose of pointing to memory locations. And you can create all kinds of crazy levels of indirection. We can do pointer equals, pointer 2, is pointer. We can do pointer 3, it's pointer 2, pointer 4, it's pointer. See, it's already getting a little weird. Pointer 2 is that. Going to do that, then that. Pointer 5, on out into oblivion. Is the computer ever going to get confused? Not unless we make a mistake, as far as the user goes, because there's certain, you can codify this in various mathematical ways, in a very general way, so that you can do any kind of crazy pointer, or any kind of level of indirection you want with a pointer. So we've sort of beat that concept to death. This right here, this little formatting that we put: regular variable, pointer variable, generalized fact about all variables. We're going to refer to this a lot, directly and indirectly, but this is the basic concept. It's very important that you get it. Pointers are variables, the value of which it points to another location in memory. Yep, we got that. Or at least we will at some point. There is no limit. Pointer can point to a pointer, which points to another pointer ad nauseum. Yep, just covered that. Let's do a little. We're done with the scratch pad for now. We got some time. We'll go here. We're gonna do. We're still on this. We're gonna search for indirection. That's the first hit that we get. So we're gonna search for indirection. It's not what we want to do. Indirection. What's the next one? Very soon in the article. References serve as a level of indirection, as we talked about. For our purposes, we're going to just sort of use references and pointers synonymously. There is some subtle difference, and pointers are a type of reference. References serve as a level of indirection, but for our purposes, again, if we say reference, if I accidentally say reference or whatnot, then just assume that what I really mean is pointer. And again, I don't want to get a bunch of crap about how that's not technically true. I don't care. For the general purposes of this, we're just going to pretend the two are the same. References. Oh my God. References serve as a level of indirection. A pointer's value determines which memory address is to be used in a calculation. Because indirection is a fundamental aspect of algorithms, pointers are often expressed as a fundamental data type in programming languages. In statically or strongly typed programming languages, the type of a pointer determines the type of the data to which it points. We will talk more about. We've talked about typing and how data is interpreted, things like that. We're going to sort of be forced at some point to sort of glaze over statically typed, dynamically typed. We should be able to sort of abstract that way abstract that concept in a general way. So this is some C code down here in the code blocks. We will. We got about 2 minutes, so we'll sort of go through this. It's not important, Are we going to learn how to program in C? Definitely not. But we're gonna. I haven't actually read this, but I have no doubt that this is basically going to say exactly what we already said. So, in some languages, a pointer can reference to another pointer, requiring multiple dereference operations to get to the original value. That's what we were showing with all the offsets and the 5 levels of indirection we were setting up with Cheat Engine relative to Shadowrun.exe. While each level of indirection may add a performance cost, it is sometimes necessary in order to provide correct behavior for complex data structures. That's something that we will get into, not in a specific way, but certainly in a general way. For example, in C, it is typical to define a linked list in terms of an element that contains a pointer to the next element of the list. What is this essentially saying? What this is essentially saying is that indirection as a concept allows you to build data structures and things in a programming language that you would otherwise not be able to build unless you have the ability to do indirection. If you did not have the ability to point to another or to refer to another memory location in the value of a variable, it would drastically cut down on the type of concepts that you could express, because you'd constantly have to be digging out memory locations and messing around with things like that. And when pointers and just the idea of having a memory location in a variable that you could dynamically refer to based on the state of an application, when that concept first came up, it completely changed how programming was approached and how programming was done, and the sort of concepts that you could express in programming languages. And so we're going to stop there and jump into this a little bit more.